polarity of a molecule. We saw why certain bonds are polar while others are non-polar. Does a polar bond in a molecule mean that the molecule as a whole is polar too? Let us find out. We saw in the previous section what possibilities exist when two atoms are bonded, as in the case of H2, HCl, and HF. If the atoms are identical or have the same electronegativity number, the bonds are non-polar, and the molecule is non-polar too. H2 is an example. If there is an electronegativity difference, then the bond is polar. Such a diatomic molecule will be polar as the arrangement is linear and there is a net dipole moment towards the right, seen in the direction of the arrow. Dipole moment is a physical quantity used to measure the polarity of bonds. HCl and HF are examples of polar molecules. What happens when we have more than two atoms together to form a molecule? Let us take the example of CO2. The carbon-oxygen bond is polar as the electronegativity of oxygen is 3,5 and that of carbon is 2,5, giving us an electronegativity difference, delta En, of 1. Since both the double bonds in the CO2 molecule are polar, we may expect the molecule also to be polar. Dipole moments come to our rescue. We can see that the two dipole moments are in opposite directions due to the linear symmetrical arrangement, and being equal vectors add up to 0. Hence the net or resultant dipole moment is 0, thereby making the CO2 molecule non-polar. Let us take the example of water, H2O. The oxygen-hydrogen bond is polar as the electronegativity of oxygen is 3,5 and that of hydrogen is 2,1, giving us an electronegativity difference, delta En, of 1,4. Now we know that we need to determine the net dipole moment before we comment on the polarity of the molecule. Since the H2O molecule is asymmetrical, a net dipole moment exists. This means that one end of the molecule is slightly positive and the other end is slightly negative.
Starting to feel it? Now go master it with Maskitv.